I'm Anil Kumar, sharing with you some application questions from previous test paper, IB vectors. The question here is, boat A moves according to x of t equals to 4 plus t, y of t is 5 minus 2t, where the distance units are kilometers and the time units are hours. Boat B moves according to x of t equals to 1 plus 2t, and y of t equals to minus 8 plus t, where t is greater than equal to 0. Now this question has many parts. I am taking 3 first and then we'll continue in the second part of the video. So first 3 are, find the initial position of each boat, find the velocity vector of each boat, show that the speed of each boat is constant, and state the speeds. Okay. So let us see what we are given. So we are given boat A. So let me write, we have x, y for both. So let me write xa for boat A, right? So that is given to us as 4 plus t, and ya with time is given as 5 minus 2t. For boat B, we are given xb of t is 1 plus 2t, and yb for t is minus 8 plus t. T is greater than equal to 0. That means starting is at x equals to 0. Now first part is find the initial position of each boat. So initial position means t equals to 0. That is kind of important, right? So if t is equals to 0, for boat A, if I write t is 0, what do I get values for x and y? If t is 0, xa will be 4, ya will be 5. Do you see that? So for t is 0, so we can get initial position as 4 and 5, correct? So we could write this as 4 and 5. So that is the initial position of boat A, and for boat B, it is going to be 1 and minus 8, correct? So it is 1 and minus 8, correct? So these values here, they give you initial position. Do you see that? That is the initial position. Let's try to understand our equation. That's the whole idea of this video, right? So these are initial positions. What did I did? I substituted t equals to 0 to find both. So this is for boat A, this is for boat B, correct? Second part is, find the velocity vector of each boat. Now, velocity vector is given by times velocity. Displacement is, let's write down the relation, okay? So we are working on speed, distance, time. So distance is speed into time, correct? So this is, you should say, velocity into time when given in vector position, right? So this is 2t. 2 is part of velocity vector along y direction. Do you get the idea? And t is time. So we could write this in, let me use this ink now. So the velocity vector is given by this part of the equation. Time into velocity, right? So find the velocity vector of each boat. So velocity vector here is 1 minus 2. And for B, it is 2 and 1, right? It is 2 and 1. So it is 2, 1. That is the velocity vector. Now, let's get back to the third part, which says, show that the speed of each boat is constant and state the speed. Okay, so let me first state the speed and then I'll also show how we can show it as constant. Now, we know velocity, this is the velocity vector, okay? So this is the velocity vector for both A and B, okay? Now, speed is the magnitude of velocity, right? So that is what speed is. So we can find magnitude for both. So for A, we say speed of A will be square root of 1 square plus minus 2 square root, correct? And speed of B will be equals to square root of 2 square plus 1 square, right? So which is 1 plus 4, which is 5, correct? So we get square root of 5. Here also we get square root of 4 plus 1, which is 5, correct? Okay. You'll also notice that these two are perpendicular to one another. So their direction is such that they are at right angles to one another. Their path is perpendicular, right? Now whenever you write speed, you should also include the units, kilometers per hour. So let me use kilometers per hour, kilometers per hour. I hope this point is clear. Okay. So we skipped one part, and that is show that the speed of each boat is constant. So how do we show that part? Well, one way is that you can calculate speed at different time or displacement at different times. That you could do. So let me make a table here. Okay, I have very limited space, so what I'll do, I'll just use a little bit, and then we will see what happens. So we have made columns here. So I'll do for one, you do for the other one. Okay, but they are kind of similar. Okay, so the boat A will write time t, and time is in hours. X value, x of t, which is 4 plus t, right? Which is 4 plus t, and then we have y value, which is 5 minus 2t. Okay, so if I substitute t as 0, I get x of t as 4 and y of t as 5. If I substitute t as 1, then we get 4 plus 1 as 5, and we get 5 minus 2, which is 3, right? Okay. If I substitute t as 2, I get 4 plus 2 as 6, and the y value will be 1. And then if I substitute 3, I get 4 plus 3 is 7, and the y value will be 3 times 2 is 6, so 5 minus 6 is minus 1. So what you see here is that there is a linear change, constant change. So as the x value changes by a unit each time, so what is happening? Each time the distance actually, the rate of change of y with respect to x is constant. This difference is 2. Do you see that this difference is 2? So what I'm trying to say is this is my common difference, delta. So in this case, since the common difference is 2, we can say it is linear, constant, correct? So that is kind of an idea for you. So it's moving at a constant rate. That's one part. You could also graph this, and you'll find that all these points will lie on a straight line, right? So as t increases, the value, the position changes from 4, 5 to 5, 3, 6, 1. So it's kind of decreasing at a linear rate, at a constant rate. Okay, that is what we're trying to say. So anyway, so there is a constant difference as x and y values change. So that clearly indicates that speed is constant. Okay, so that's one way of doing it. And we have already calculated the value, which is square root of 5. You can do the same calculations for the second boat also. And what you can also do is kind of plot it. If you plot it, you will see that the graph of the first one will start at 4, 5. Let us say, okay, let me use 2 different inks. And then it is going to move 1 minus 2 kind of. So let's say it starts kind of here, and it moves 1 minus 2 means x1, y2. So kind of it moves like this, right? So the other boat starts at 1 minus 8. So it starts at 1 minus 8 and much below, and then it moves to 1 kind of upwards. So we could write that or show it in this fashion. So I don't know really where they meet, but kind of like this. Is it okay? So approximately I just drawn roughly. And what you notice here is that these boats are, their paths are at right angles, right? So I'm not saying this is very close to x-intercept, but just drawing them as a rough diagram. So they are also, you can compare these directions. These directions indicate clearly that they're heading are perpendicular to one another. Anyway, so this gives you a lot of information about the velocity from the displacement vector, which you've seen in this example. We'll continue to find the shortest distance between these two boats. That is a very critical question to understand. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.